Paper 2, question 25. Brace yourself, this one is a beautiful question. 6 marks. Solve the simultaneous equations. X squared plus y squared equals 9. And x plus y equals 2. Give your answers correct at 2 decimal places. Now, simultaneous equations, the instinct when you see these as far as sort of exam practice and trying questions are concerned is that a lot of people try to solve by elimination is the first one that they go for. What you really want to be in the habit of doing as the first one you look at, particularly for those who want to do A-level, is solving simultaneous equations by substitution. That's where you change one of the equations into either x equals the rest of the stuff or y equals the rest of the stuff. And then you use that to substitute into the other one. So for example, this here, x plus y is 2. If I get y by itself, if I take x away from both sides there, I'll end up with this. And because y features in the other equation, what I can then do is substitute that in for y there. And we end up with an equation with just one letter and numbers, and you can solve it. Because at this point in time, both of these equations on their own are useless, so you need to bring them together. Elimination is not possible with this, because they've thrown a curveball at you in the sense that they've given you x and y squared terms. There are other situations as well where elimination will not work. Substitution will always work. So it's of the 3 types of ways of solving simultaneous equations. The other, by the way, is graphically, so drawing the graph of each of these. I'm assuming at GCSE, not many of you will know that's the equation of a circle when you look at this instinctively. So drawing the equation, drawing the graphs and then reading the results from that isn't very feasible. Substitution's the way to go. So that there, when you arrange your second equation, you've got this. Substituting it into the top equation, I end up with x squared plus open bracket. Very important that you use your brackets here. All squared, and that equals 9. 2 minus x all squared is the same as having 2 minus x, 2 minus x. Just as a sort of gut feeling instinct, the fact that x squareds are involved, you're very, very likely most of the time to end up with a situation where you're going to have to factorize because you're going to end up with a quadratic. So I know in this question that you're going to need an equals 0. So I'm just going to go ahead and take 9 away from both sides. So disappear here and reappear on this side, so that I get r equals 0. Just getting it out the road because we're going to need it. And that's what we have there. Okay. If we break out this bracket, I end up with 4 when I do 2 times 2. I end up with minus 2x that happens twice over when I do our outside and inside. And the last 2 give me a plus x squared. I still have this take away 9 here. I still have an equal 0. And I still have an x squared plus at the start. Okay. If I add together the x squareds, if I do plus 4 take away 9, and if I do take away 2x, take away 2x, I end up with, where are we? 2x squared, take away 4x, take away 5, equals 0. So as it's turned out, it is a quadratic we're using, so we need to try and factorize that, or at least that's the instinct. We have an x squared term and an x term, we're going to look to put these in 2 sets of brackets, and then all will be well when we split it up. However, the sting in the tail in this question, as if it wasn't tricky enough already, I know that that's not going to factorize because of a little thing in the question. It talks about 2 decimal places. Now, whenever you deal with quadratics, your instinct will always be to factorize. You get an equals 0, then you follow a process of factorizing and split it up into 2 equations and solve. But when you have decimal places or significant figures being told you need to do in the question, that basically tells you that your answers are ugly. So it's not going to factorize nicely, because when it factorizes, your answers are generally quite, they are nice. This is a case of when it doesn't factorize, or when you're given that, when you're told that you're going to have to give it in decimal places or significant figures, you need to use the quadratic formula, which is that monstrosity you're given at the start. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And that applies only when you have ax squared plus bx plus c equals 0. So the importance of getting this equals 0 is it's absolutely essential. It doesn't matter if you're factorising or not. You need an equals 0 before you can do anything. From that, it should be okay to quote that a is going to be 2, b is going to be negative 4. This is a good habit what I'm doing here, doodling stuff on the side. And c is going to be negative 5. Okay. When I plug in each of these, and be careful with the negatives, get that bracket around it, otherwise you might end up making a mistake when you go through this. X is going to be minus 4 plus or minus the square root of negative 4 squared minus 4 times 2 times negative 5, and that's all over 2a. Okay, what you end up with after that is, if you deal with that minus 4 at the beginning, you end up with a plus 4. If you deal with that negative 4 squared in the bracket, you end up with 16. And if you deal with that take away 4 times 2 times minus 5, you end up with a plus 40. So just highlighting there in red. Oh, there's one other thing I forgot about. Yeah, it's not 2a, it's 2 times 2. And then when you tidy up the 2 times 2 in the bottom, you end up with, no, that's right, you end up with 4. So nothing else has changed other than what's in red there. X equals that. Okay. What you tidy up next is that this is going to be the square root of 58, which I'll just doodle up there. That's the only thing that's going to change in that next line. What we have now is this plus minus situation. It basically means that x is all of this with just a plus and all of that with just a minus, and that's where you get this split to give you the two answers. So one answer is that x is going to equal 4 plus the square root of 56. Don't know why I put 58 here, I'm having a nightmare. 56 all over 4. And x is also going to equal 4 minus the square root of 56 all over 4. When you type those into the calculator and get your answers, x is going to be 2.87 for the first one. And x is going to equal minus 0.87 for the second one. It asks you for 2 decimal places, so I've rounded there. Think you're done? Not quite. Those are the x coordinates of our answers. We also need the y coordinates of our answers. So we need to substitute both of these back into one of the equations at the beginning. Now, always choose the easier one to do. X plus y equals 2 is the nicer one. And given that right back at the beginning we rearranged it to that, I'm going to sub it into that. So 2 minus x is what we need to do for both of these. So y for this one is going to be 2 take away 2.87. Y for this one is going to be 2 take away negative 0.87. Which basically gives us the opposite answers from what we had there. X and y effectively have same answers in each one, but they go with each other. So 2.87 minus 0.87 is one of the points where this circle and this straight line meet each other. The other point is minus 0.87 on 2.87. And they've just given you x equals y equals to put into. The key thing to note is that the first row says x equals and then y equals. That would go, say, in the top one, and then it says or, that would go in the second one. Or vice versa, as long as you make sure that those two values for x and y are together, and that those two values for x and y are together, then you'll get full credit.